We can use the knowledge that we have gained to calculate areas of irregular figures. We can think of partitioning a figure into some recognizable figures, calculating their areas separately, and then adding or subtracting the parts to make the figure we desire. Review the formulas for area that we have discussed, and then let's look at some examples involving area. In this section, we will assume that figures that appear to have square corners, that is, right angles, do, and that sides that appear parallel are. In other words, if a figure looks like a rectangle, we will assume that it is one. Example 1. Find the area of the given figure. Before we can calculate the area of the figure, we must first identify the figure. This is a parallelogram. Recall that the formula for the area of a parallelogram is A is equal to B times H, where B is the base and H is the height to that base. In the given figure, the base is 10 feet and the height is 5 feet. Substituting these values into the formula, we get A is equal to 10 times 5. Solving for A, we get A is equal to 50. Thus, the area of the parallelogram is 50 square feet. Example 2. Find the area of the isosceles trapezoid PQRS with bases of 15 centimeters and 21 centimeters and legs of 5 centimeters. First, make a drawing and enter the given information. Recall that the formula for the area of a trapezoid is A is equal to 1/2 times the sum of the bases times the height. We are given the lengths of the bases, but we must calculate the height of the trapezoid. Because the trapezoid is isosceles, we know that line segments PT and QU are placed perpendicular to the bases, or in other words, the heights partition the trapezoid into rectangle PQUT and two congruent triangles PTS and QUR. Thus, line segment TU is 15 centimeters long, and line segments ST and RU are each 3 centimeters in length. Notice that the triangles PTS and QUR are both 3, 4, 5 right triangles. Thus, the height of the trapezoid PQRS is 4 centimeters. Now that we know the height of the trapezoid, we are ready to substitute the values into the formula. This gives us A is equal to 1/2 times the sum of 15 plus 21 times 4. Solving the equation, we get A is equal to 72. Thus, the area of isosceles trapezoid PQRS is 72 square centimeters. Example 3. Find the area of the shaded portion of this composite figure. Notice that the figure is composed of 3 basic figures, a triangle, a square, and a circle. We will begin by finding the areas of these basic figures. The area of the triangle can be found using the formula A sub 1 is equal to 1/2 times the base times the height. Substituting 7 for the base and 3 for the height, we get A sub 1 is equal to 1/2 times 7 times 3. Solving for A sub 1, we get A sub 1 is equal to 10 and 5/10 square centimeters. Next, we will calculate the area of the square. The formula A sub 2 is equal to S squared can be used to find the area of the square. Substituting 7 for S, we get A sub 2 is equal to 7 squared. Solving for A sub 2, we get 49 square centimeters. The last figure that we need to find the area of is the circle. To calculate the area of the circle, we will use the formula A sub 3 is equal to pi r squared. Because the formula is given in terms of r and we have the diameter of the circle, we must first calculate the radius of the circle. Remember that the radius of a circle is 1/2 the diameter of the circle. Therefore, the radius of the circle with 3 centimeters diameter is 1 5/10 centimeters. Now we're ready to make the substitutions into the formula. A sub 3 is equal to 3 14/100 times 1 5/10 squared. Solving for a sub 3, we get a sub 3 is equal to 7 65/1,000 square centimeters. Look again at the drawing. We see that the area that is shaded is the area of the triangle plus the area of the square less the area of the circle. Writing an equation, we have the total shaded area is equal to a sub 1 plus a sub 2 minus a sub 3. Substituting the values that we have found into the equation, we get the total shaded area is equal to 10 5/10 plus 49 minus 7 65/1,000. Solving for the total shaded area, we get 52 435/1,000 square centimeters.